process is setting up the lighting. A common approach is to override all the materials in the scene with a neutral color in order to focus on the lighting. In this lesson, we'll explore how we can do that using the Material Override feature. First, open up the Asset Editor, and you'll see that there are already some materials assigned to the models in our scene. Now, click on the gear icon to go to the V-Ray settings and find the Material Override tab. It's the second from the bottom. Toggle the switch on to enable it, and then let's start an interactive render. As you can see, all the objects are now using this gray color. This happens only at render time and does not affect the materials you have already applied. You can also change the override color if you want to, but generally, a mid-gray color should work okay. You can also use some of the materials you have already assigned in the scene. This way, you can preview certain material characteristics such as reflections, for example. In our case, let's use the concrete main material, as it is the most used material in our scene. Now that we have a simple material setup, in this lesson, we will focus on the lighting. In many exterior scenes, one of the most commonly used tools is the V-Ray Sun and Sky. It is a powerful system that enables you to achieve all sorts of natural lighting. One of the first things you'll often want to do when lighting an exterior is to set up the sun angle. By default, V-Ray is using the Rhino document sun, and its position can be controlled via Rhino's sun panel. Go to the Render tools on your toolbar, and let's click on the small sun icon. Then, in the window that pops up, let's check manual mode and try out some different angles. Note how changing the sun position also affects the sky and the entire illumination that comes from it. You will also notice that the sun altitude affects its color and intensity, similar to how it occurs in real life. I'm going to set the azimuth angle to 155.7 degrees and the altitude to about 33 degrees. Once you've got your sun angle set, you can further control the properties of the sun and sky system using the V-Ray Asset Editor. Head over to the Lights tab, and with the sun selected, click on the small arrow to access its settings. Here you can multiply the intensity of the sun, but note that it also affects the sky. Most of the time, you'll probably want to just stick to the default value of 1. Now, you'll also notice that the shadows caused by the sun have pretty crisp edges. You can increase the sun size multiplier to make them softer, without affecting the light output of the sun itself. Let's use a value of 3 for our scene here. From here, you can also change the sky model. Click on the drop-down menu to choose from different models, and notice how each has a different color gradient and properties. For example, with the CIE models, you have the ability to control the intensity of the sky itself, separate from the sun. We'll take a further look at these options in another lesson, so for this scene, let's stick to the default HOSEC sky model. Lastly, let's try out some different values for the turbidity parameter, which simulates the amount of dust in the air. Move the slider left or right, and notice how it affects the color of the sky, making it appear a more orange and hazy gray with higher values, and a clear blue when using lower values. Let's settle on a turbidity value of 2 for our scene. By design, rendering with V-Ray feels very much like taking a picture with a real camera. And in order to get a nice image, you'll need to set a proper exposure value, just like in real life. In this lesson, we'll explore how to use the basic V-Ray camera settings to quickly expose and white balance your composition for rendering. In the frame buffer here, you can see that the image is overall a bit too dark. Using the exposure settings, I'll show you how we can easily fix this. First, go to the Render settings, and under the Camera tab, locate the exposure settings. Notice how moving the exposure value slider to the left and to the right makes the image darker and brighter respectively. Let's set it to 13.5, remembering that lower values result in a brighter image. Once again, just as in photography, you can also use the white balance setting to remove any undesired color tint from objects that should appear white. Let's try making the walls of the house white. An easy way to do this is to set the white balance color to match the color you're trying to neutralize on the objects that should be white. For our scene, I'm going to set the white balance slightly warmer, to an off-white seashell color. One last thing we can do quickly and easily here is straighten the vertical lines of the image. As you can see in the frame buffer, using a wide-angle lens can result in too much perspective distortion. Sometimes this is a desirable effect, but typically, when rendering architectural scenes, the vertical lines of the building should be parallel. In the camera settings here, let's expand the Effects tab and adjust the vertical tilt to fix this. Let's set it to 0.4. Now, you can disable the material override as well. And let's move on to the next step. In this lesson, we'll explore another popular method for lighting an exterior scene by using the V-Ray dome light in combination with a 32-bit panoramic image in order to produce image-based lighting. This is commonly achieved with the use of HDRIs, or high dynamic range images, which can represent a broad range of luminosity that is similar to the range experienced by the human eye. From the V-Ray toolbar, let's choose the dome light and click once anywhere in the viewport to place it. Its position doesn't have any effect on the lighting it produces, and V-Ray will automatically prompt you to pick an image. You can choose one of the images provided from HDRI Haven. In this case, I'm going to select the Kiara 1 Dawn 3K image. A quick internet search can also help you find more HDRI images, and there are many which you can download for free. Now, open up the V-Ray Asset Editor and click on this icon to disable the Rhino document sun. Then let's start an interactive render. You'll see now that the entire scene is lit solely by the dome light. Note that the render is also too dark. This is because the intensity and brightness of HDRI images can vary significantly, so you'll need to manually adjust the light intensity accordingly. V-Ray makes this easy for you by providing a quick shortcut to the intensity parameter. For our scene, I'm going to set the intensity to 20 here. Now, open the flyout menu here to the right. Since these images are panoramic, they can also be rotated around their axis, as if you were moving the sun and sky around. This changes the lighting pretty dramatically. To do this, click on the dome light's texture to access its properties. Drop down the Texture Placement menu, and let's try out some different values for the Rotate H slider. You can also experiment with different HDRIs by clicking on the file folder under the bitmap section. Again, note that each HDRI produces significantly different lighting results. Play around with rotating them in your scene to get a sense of how they can impact the look and feel of your composition. For my scene, I'm going to select the Cloud Layers 3K HDRI and set the rotation to 265. I'll then press the back option and increase the dome light intensity to 50. Now, I'm going to drop down the Options panel and check the box next to Invisible. As you can see in the frame buffer, the dome light HDRI is no longer seen by the camera, but its light is still affecting the scene. Now let's close the Options menu. On a last note, you can use solely a dome light to light an exterior scene, or use it in combination with the V-Ray sun. If you go this route, just make sure that the V-Ray sun position roughly corresponds to the position of the sun in the image. Now, let's close the Asset Editor and stop the VFB, and we're ready for the next lesson. In this lesson, we're going to discuss the V-Ray proxy. V-Ray proxy allows geometry to be imported from an external mesh at render time only. This makes it a powerful memory optimization tool, since the geometry is not present in the Rhino scene and does not take up any resources. As a result, this enables the rendering of scenes with millions of triangles, more than Rhino itself can handle. And importing and exporting proxies in Rhino takes only a few clicks via the V-Ray object tools. Let's take a look at how we can benefit from using the V-Ray proxy in our scene. First, open the Palm Tree 3DM file that has been provided with this lesson. Now hit Render, just so we can see what the tree looks like. Let's also explore the materials that are present in the scene. As you can see, there are 3 objects, and each has a different material applied to it. It's important to apply some materials to the different parts of your model before exporting it to Proxy, so that you can adjust them later on. Now, let's select all the meshes and navigate to the V-Ray tab and click on the Export as VR Mesh button. From the dialog box, specify the name of the V-Ray proxy object. In this case, I'll call this Palm Tree and pick a location where to create the VR Mesh file. For the other options, you can typically just stick with the default settings. Just make sure that Replace Object with Proxy is checked, so that the geometry will be automatically converted to a proxy and loaded in the scene at the same position. Now let's click the Export button. You can now see that we end up with a really simplified version of the tree in the viewport. However, when you hit Render, you'll notice that the high-quality tree appears again in the image. Let's check the Materials tab and take a look at the new material that has appeared there, called Palm Tree Material. This is a multi-material which is used to shade V-Ray proxies. As you can see, all three materials that we had previously assigned are now contained in the multi-material. Now let's go to the Geometry tab, where you'll see our Palm Tree proxy is listed. All the proxies that are in the project will appear here. You also have a couple of options, such as specifying the proxy file path or changing its preview type for the sake of viewport performance. Note that when using the preview type whole mesh, the entire mesh will be displayed in the viewport, which can potentially put a substantial load on your system. Back in the project file, let's import the proxy we've just generated. Click on the Import VR Mesh icon, and from the Assets folder, browse for the Palm Tree VR Mesh file, and then click anywhere in the scene to place it. Now with the tree selected, click on the Edit V-Ray Material icon to select its material. Now let's start the IPR preview to see how it looks. You'll notice right away that the proxy's materials look different here. Once again, the proxy has been assigned a multi-material containing 3 generic materials. However, when you import a V-Ray proxy, it's going to have only generic materials assigned. It does not save the material settings stored in it. As a result, you can either edit the generic materials manually or substitute them with existing materials. For example, to edit the materials, let's click on the texture icon for submaterial 0, and then select the color swatch to edit the diffuse color. Adjusting the sliders, you'll see that in the frame buffer, I am setting the color for the palm tree's trunk. Now, it's important to note here that in your scene, you may discover that the order of these submaterials is entirely different. To avoid any confusion in the next steps, go ahead and open the multi-material in your scene and adjust the diffuse color for each submaterial while the IPR is running. That way, you'll determine which part of the palm tree each submaterial color is assigned to. In my case, submaterial 0 is assigned to the trunk, so I'll set it to a gray shade of brown. I will also do the same thing again for submaterial 1 to confirm which leaves I'm setting the color for on the palm tree, and I'll choose a yellowish green color. Now, editing materials manually this way is a bit tedious, and if I have to do this for each tree, I can't easily make changes to all of their materials. Thankfully, once you understand how the submaterials are assigned to the different parts of your proxy, we also have the option to simply apply an existing predefined material to each. To do this, let's go back to the multi-material, and for submaterial 0, click on the drop-down arrow. This will show a list of all the materials in the project. Since I know submaterial 0 is assigned to the trunk in my scene, I'll select the palm bark material, and you'll see in the frame buffer that the proxy's trunk updates right away. Now, I'll do the same thing for the other 2 material slots. Let's assign the palm leaves dry and palm leaves materials accordingly. When you're done, go ahead and stop the IPR and close the frame buffer and the asset editor. Whenever you are going to copy a proxy to use it multiple times, a best practice is to put it inside a block. This is Rhino's method for handling instances, and it works for V-Ray proxies just as it does for any Rhino object. With the tree selected, go ahead and type block in the command line and hit enter. Next, click once on the base of the trunk, and in the pop-up window, specify the name of the block. I'll name this one palm. Now, let's move the palm to a more appropriate location. Type move and select the move command, and then click somewhere on the base of the tree. Now let's reposition our view a bit and find a good position to place the tree. Next, type copy to use the copy command, and again specify some point at the base of the proxy. Then, let's switch to the top view and click to create instances of the proxy. I'm going to place several instances around the borders of the scene and in the center here, where you'll see there are red guidelines. You can place them on the guidelines as well, or position them wherever you'd like. You can also rotate some of them just to have some variation. I'll also switch back out of top view and scale some of the trees as well. Later on in the grasshopper chapter, we are going to explore some powerful techniques to automatically scatter a large number of proxies. For now, when you're finished planting trees, go to the Panels menu, select Named Views, and then double-click on the Render Camera view, and let's move on to the next step. In this lesson, let's take a look at how we can quickly create grass by using the V-Ray Fur. Similar to the V-Ray proxy, it can be used to create really complex geometry that is only generated at render time. Let's select the green poly surface called Grass Patch, and then from the V-Ray toolbar, click on the fur icon. Now, let's start an interactive render. To get a better idea of what's going on, you can zoom in on the grass. Do so either by navigating or double-click on the grass close-up view. As you can see, we already have some grass-shaped geometry, but we can adjust some of its settings to make it look more trim. Go to the Geometry tab of the Asset Editor, select the fur object, and click on the Flyout menu to roll it out. Let's also draw a region in the render to get faster feedback for any adjustments we make to the grass. In the Asset Editor, you can control the density of the grass using the Count slider. Just be mindful that higher values can produce enormous loads of geometry, which may take a lot of time to generate. It can also cause your workstation to run out of memory, especially when applying grass on large surfaces. In our case, we can use a lower value. Let's set the grass count slider to 0.4. You can also control the overall length of each strand. Let's set ours to 5. We can also increase the grass thickness so that it doesn't look so scarce. I'll set the thickness to 0.5. Let's also decrease the taper amount so that the grass isn't so spiky, but rather freshly cut. I'll set this value to 0.33. Lastly, you can also decrease the bend amount as well. Let's set it to something fairly mild like 0.3. Now, if you click to drop down the Variance menu, you'll see that there is already some variety in the length and thickness of the grass strands by default, which should be enough for this type of grass. Finally, let's apply a material to the grass. As you can see, the fur object has its own material slot, in which you can specify any of the materials in the scene. Go ahead and click the switch to enable the material, and then click the drop-down menu and choose the Grass E 200 cm material. Now, close the Asset Editor, disable the render region, and let's switch back to the main camera to see how the grass looks from a distance. Now let's discuss the V-Ray aerial perspective, which is an atmospheric effect that is similar to fog or haze. It is especially useful for creating a sense of depth when rendering exterior scenes. Open up the Asset Editor, and let's head over to the Settings tab and click on the Flyout menu to expand the options. Then, navigate to the Volumetric Environment tab, and let's flip the switch on. You'll notice immediately that the frame buffer updates to show the effect. Now let's click to drop down the Volumetric Environment menu and review the settings. An important thing to keep in mind here is that the aerial perspective is dependent on the position of the sun. Even if your sun is disabled, its position still affects the color and intensity of the aerial perspective. The visibility range controls how thick the fog is. Lower values like 60 result in a thicker fog, while higher values will make the fog less thick. I'm going to set the visibility to 3000. You can also play around with the atmosphere height. Lower values enable more direct light to reach the scene, while higher values will scatter the direct light. Note that this scatter effect is only present when the Effect Environment switch is enabled below. I'm going to set this value to 60. You can also make the aerial perspective brighter or darker using the Inscattered Light multiplier to scatter the sunlight. However, only the default value of 1 is physically accurate. There's also an option to tint the aerial perspective using the filter color. Click on the color swatch, and let's make our scene a bit more blue. Lastly, the Effect Environment option determines whether or not the aerial perspective has an effect over the illumination from the sky. You can turn it off. Okay, when you're ready, close the Asset Editor and stop the interactive preview, and let's move on to the next step. So far, we've only been rendering for preview purposes. In this lesson, let's make a high-quality render of our image. First, open the render settings and disable the interactive mode so that it automatically switches to progressive mode. Then, let's move the quality slider to high, and then let's also enable the denoiser to take care of any remaining noise. Next, drop down the render output settings, and let's increase the resolution to something higher. Feel free to set it to something that works well for your machine's hardware, knowing that the larger the resolution, the longer it is going to take to render. In my case, I'll set it to 1280 by 1600. Now, let's also go to the Layers list in Rhino and click the bulb to unhide the accessories. It contains some objects that aren't crucial for the overall image look, and as such, they were kept hidden so as not to distract us while working on the major aspects of the image. Now, when you're ready, go ahead and hit the Render button. You can then either wait for your image to render, or you can stop the render and load the example one by clicking on the folder icon. In the Assets folder of this lesson, you'll find the Exterior Day Final VR image file. Note that this file also contains a denoised version in the render elements. Now you can apply some color corrections. I'm going to check on the exposure controls and use the highlight burn to reduce the exposure of the overbright areas. Just be careful not to go too low, as this can flatten down the image. From here, let's also adjust the white balance of the image, though this will not be as correct and precise as adjusting the white balance in the camera settings. I'm going to slide it up to 6952 to make the image slightly warmer. Next, let's experiment with the color balance and make the shadows a little warmer and the highlights a little cooler. Lastly, I'm going to use the curve to punch up the tones for more impact by adjusting the sliders to form a more pronounced S-curve shape. Alright, once you're happy with your final image, go ahead and save it. In this lesson, we'll explore how we can turn our daytime render into a nighttime version. First, we'll need to take care of the environment lighting. To start, open the V-Ray Asset Editor and let's disable the sun. Then, open the flyout menu to the right and let's click the texture icon to replace the HDRI image with something more dusky looking. Let's choose the Venice Night 4K image. Then, hit back and let's lower the intensity value to 2. Now, drop down the Options menu and uncheck the box for Invisible so that we can see the HDRI in our render. It's also a good idea to change the exposure value of the camera as well. This way, you won't have to use huge values for the intensity of the artificial lights we are about to create. Head over to the Settings, drop down the Camera menu, and let's set the exposure value to 9. Finally, let's also disable the aerial perspective by switching off the volumetric environment. Now, to speed things up a bit while working on the lighting, you can lower the resolution again to something like 640 by 800. Then, enable the switch for the material override. There are still some materials we don't want to be overridden though. In the Materials section, search for the glass material from the list and drop down the material options to uncheck the Can Be Overridden setting. Let's also repeat this same step for the water material. Okay, now let's do a render to see how everything looks so far. And so far so good. Go ahead and stop the render and let's close the frame buffer. Now it's time to add some artificial lights. To make things easier, you can switch to multiple viewports by double-clicking on Render Camera here. We're going to start with the interior lights. The V-Ray Sphere light is ideal for providing general lighting. so go ahead and click on that in the toolbar. Now in the top view of the viewport, you're going to see a few yellow guide markers, which you can use to place the lights. Of course, feel free to position the lights to suit your own preference as well. With the Sphere Light tool active, click once and either drag the mouse to adjust the radius, or directly type in a value for it. For example, 50 should be okay. Select the point light and use the copy command to create a few other instances of the light. In my case, I'll position them on the yellow guideline markers. Once you're ready with the lights on the lower floor, create one more copy to use for the upper floor. Then click the Make Unique button. This will enable us to have separate control over that light, to use different colors from the lights on the lower floor. Go ahead and move it up to the upper floor in the front view, and then make a few more evenly spaced copies to cover the entire upper floor. Now let's select the bollard lights in the garden. As you can see, there are multiple block instances of them. Use the Block Edit command and select one of them. Then, click once on the V-Ray Mesh Light icon on the V-Ray toolbar and press OK in the pop-up window. Now, all the block instances are mesh lights. Next, let's add some lights to the pool as well. Select the pool and use the Isolate command to temporarily hide all of the other objects. Now select IES Light and in the top view, click near the right edge of the pool. You can either drag the mouse to set the radius or type in 150. Then, drag to the left edge while holding Shift and click once more. You'll be prompted to choose an IES file. Go ahead and select the IES01 file provided within the Assets folder. You can then make a few copies manually, or use the Array command to quickly add more lights. If you're using the Array command, set the X value to 1, Y value to 4, and Z value to 1. Click and drag on the base of the light to space out the copies. Once you've got all the copies, move them down in the front viewport to submerge them in the pool. Then when you're ready, use either the Unisolate or Show command to make the rest of the scene visible. Finally, you can select the two palm trees on the sides of the house and isolate them as well. Now let's create two rectangle lights, and I'll disable snapping so that they don't snap to the leaves of the palm trees. Using the different viewports, I'll position the lights at the base of each palm tree respectively. Then, rotate them so that they are also both pointing up. When you're finished positioning the lights, use the Show command to make the rest of the scene visible again. And then double-click to select the render camera again. Now let's make some adjustments to the settings of the lights we have placed. Go ahead and open up the V-Ray Asset Editor and right-click on each set of lights to rename them. You can also choose Select in Viewport to confirm which set of lights you're working with. Okay, let's start an interactive render and then draw a region around the lower floor so we can make adjustments to the lights more quickly. In the Asset Editor, make sure you've got the lower ground floor lights selected and click the color swatch to make the lights a bit warmer. Then let's increase their intensity to 120. Since the lights are placed freely without any fixture, we'll also need to drop down the Options menu and make their shape invisible to the camera by checking the box for Invisible. However, you'll notice that we can still see the light sources in the windows. To fix this, we'll also need to uncheck Affect Reflections. Now you can play around with the lights on the upper floor. Following the same steps as before, I'm going to redraw the render region for the upper floor, select the ground floor lights, and change the lights to a warmer color. I'll then increase their intensity to 200. Once again, I'll also drop down the Options menu and check Invisible and uncheck Affect Reflections. Now I'll redraw the render region again for the garden lights and select them. You can use a color for the garden lights, but this time I'm going to use a texture. I'll click the texture icon and select the temperature texture, and then change the mode to temperature. This mode is ideal for lights since you can specify realistic colors based on temperature values, just like real-life artificial light sources. For our scene, I'll set the temperature to be fairly warm at 3500 degrees Kelvin. Then, press back, and let's also change the intensity to 330. Now select the pool lights, and let's make them brighter. By default, the IES lights take their intensity from the IES file. However, we can override this by clicking the checkbox next to intensity, so we can set any value we'd like. Let's try something quite high, like 150,000. Finally, let's redraw the render region around the tree on the left and select the tree lights. I'll set the intensity to 75 and then use the color swatch to make them a nice warm shade of orange. You can then redraw the render region around the tree on the right to see how it looks there as well. Then turn off the render region to get a feel for the entire image. Okay, once you're ready, go ahead and stop the IPR. Now, head back to the settings and switch off the material override. Let's also switch off interactive rendering so that we render using progressive mode. Now let's render the image to see what it looks like. While it's rendering, you can also take your time to apply some color corrections to suit a night scene. Feel free to experiment with your own settings, or you can base yours off of mine. Finally, when the render is complete, you can open up the lens effects settings and check on the bloom effect, bloom mask intensity, and glare effect. Play around with these settings to create a soft bloom and glare effect for the lights in your scene.